Welcome to Science Snippets, Fun Facts, and Trivia. Today, we bring you the dinosaur extinction wasn't just an asteroid, uncovering the real cause. Let's start with what most of us were taught in school about 66 million years ago. A massive asteroid, roughly 10 kilometers wide, slammed into what is now the Yucatan Peninsula in Mexico. This event is believed to have triggered catastrophic changes on Earth, leading to the extinction of around 75 of all species, including the dinosaurs. The asteroid's impact is thought to have caused immense wildfires, tsunamis, and a nuclear winter effect, where dust and particles blocked out sunlight, severely cooling the planet. The key piece of evidence supporting this theory is the Chicxulub crater. Discovered in the 1990s, this massive crater, over 150 kilometers in diameter, is a stark reminder of the event. Around the same time, geologists identified a thin layer of sediment around the world, called the Chicxulub boundary. This layer is rich in iridium, a rare element on Earth, but common in asteroids. It acts like a global fingerprint of the asteroid impact. But while the asteroid theory is compelling, it doesn't explain everything. Some scientists argue that the asteroid impact on its own might not have been enough to wipe out all dinosaur species. After all, life is remarkably resilient, and species have survived extreme events in Earth's history. The question is, could there have been other factors at play that made the extinction so complete? Around the time of the dinosaurs' extinction, Earth was undergoing massive environmental changes. One of the key factors was intense volcanic activity. In particular, the Deccan Traps in what is now India were spewing vast amounts of lava and gases into the atmosphere. These eruptions released sulfur dioxide and carbon dioxide, which likely caused significant shifts in climate. The volcanic gases would have contributed to global cooling by blocking sunlight. But at the same time, increased CO2 levels could have led to longer-term warming. The Deccan Traps represent one of the largest volcanic events in Earth's history, with some eruptions continuing for hundreds of thousands of years. The vast fields of lava covered large parts of the Indian subcontinent and pumped enormous amounts of ash and gases into the air. This not only impacted the climate, but also affected the chemical composition of the oceans, leading to ocean acidification. As the oceans became more acidic, marine life, including plankton, which forms the base of the food chain, was severely impacted. As the environment became more unstable, ecosystems started to collapse. With temperature fluctuations, acid rain, and changes in sea levels, many plants and animals couldn't adapt fast enough. Even before the asteroid impact, the world was already experiencing extinctions. These changes likely weakened ecosystems, making the impact of the asteroid even more devastating when it did occur. The combination of volcanic activity and a cooling warming cycle set the stage for a catastrophic extinction event. The ecosystems of the late Cretaceous period were incredibly complex, with dinosaurs dominating both the land and the food chain. However, this complexity also made the ecosystems vulnerable to disruptions. When the climate started to shift due to volcanic activity and the asteroid impact, plants and primary producers at the base of the food chain began to suffer. Herbivorous dinosaurs, which relied on these plants, struggled to find enough food, and as their populations declined, so did the carnivores that preyed on them. This domino effect led to a collapse of the food web, which no species could survive unscathed. The combination of sulfur dioxide from volcanic eruptions and the debris thrown into the atmosphere by the asteroid created a toxic mix. Acid rain began to fall, devastating plant life on land and altering the chemistry of freshwater ecosystems. At the same time, the oceans were becoming more acidic, further damaging marine species, especially those with calcium carbonate shells, such as mollusks and certain plankton. With the oceans in turmoil and the land under environmental assault, entire ecosystems were thrown into chaos. While dinosaurs are often the focus of discussions about this extinction event, it's important to note that they were not the only victims. Marine reptiles like mosasaurs and plesiosaurs vanished, along with countless species of plants, insects, and even some small mammals. The biodiversity of Earth plummeted during this time, and it would take millions of years for life to recover to anything close to its former levels. This suggests that the extinction was a global phenomenon, impacting nearly every ecosystem on the planet. While the asteroid impact is often credited as the main cause of the dinosaurs' extinction, many scientists now believe it was a combination of factors. The asteroid's collision with Earth likely delivered the final blow, but the environment had already been destabilized by volcanic activity. From the Deccan Traps, the sulfur and carbon emissions from the volcanoes had already begun, cooling the planet and disrupting ecosystems. So, when the asteroid struck, it accelerated a process that was already underway, amplifying the effects of both events. Beyond the asteroid and volcanic activity, Earth was already experiencing significant environmental stress. Sea levels were fluctuating, causing the loss of coastal habitats. Volcanic gases had already altered the atmosphere, reducing the amount of sunlight reaching Earth's surface. Additionally, the planet was undergoing changes in temperature that were pushing species to their limits. This cumulative stress weakened ecosystems, making them more vulnerable to sudden, catastrophic events like the asteroid impact. Given all these factors, volcanic activity, climate change, acid rain, ocean acidification, and the asteroid impact, one has to ask, was the extinction of the dinosaurs inevitable? Some paleontologists argue that, even without the asteroid, the dinosaurs were on the brink of collapse due to the many environmental pressures. Others believe the asteroid was the decisive factor, pushing the planet past a point of no return. What's clear is that the extinction was not the result of one event, but a combination of natural disasters that overwhelmed life on Earth. The extinction of the dinosaurs offers us valuable lessons about the fragility of life on Earth and how quickly environmental changes can lead to disaster. Today, we face our own environmental challenges, particularly with climate change. Rising global temperatures, ocean acidification, and habitat destruction mirror some of the conditions that contributed to the dinosaurs' demise. By studying the past, we can understand how interconnected our ecosystems are and why it's crucial to take action before it's too late. Mass extinctions are not unique to the dinosaurs. In fact, there have been at least 5 major extinctions in Earth's history, and some scientists believe we could be heading toward a 6th. With rapid biodiversity loss and climate shifts, many species are at risk. Human activity has a direct impact on the environment, and while we have the power to cause destruction, we also have the knowledge and tools to prevent it. Learning from the past, we must be vigilant to avoid triggering another extinction event. Perhaps the biggest takeaway from the dinosaurs' extinction is that no species is immune to nature's forces. The dinosaurs ruled the Earth for over 160 million years, far longer than humans have existed. Yet, in a relatively short period, their dominance ended. Today, humans are the dominant species, but our future is uncertain if we fail to protect the environment. By understanding the factors that led to the dinosaurs' extinction, we can better prepare for and mitigate the risks we face in our own time. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.